What if I told you your network is making terrible routing decisions right now? In this video, I'll show you how to take control of spanning tree protocol like a network ninja, forcing switches to use your preferred paths by manipulating costs and priorities. Watch as I turn blocked ports into active links with just one command.
In the previous course, we saw that switch C was designated as the root bridge, and that switch B had to deactivate its port 45 because it lost the battle with switch A. We will now see how to choose or even the root bridge. For example, we would like switch A to become the chosen one. For that, we will use the command spanning tree vlan root primary. In the example, we specify vlan1 and we execute this command on switch A. This command is a kind of macro, which will lower the priority of the switch directly in the running config file. And as here we use the spanning tree by vlan, it is possible to modify the priority for each vlan. If now we look at the running config file, we can see that the priority of switch A has gone from 32769, which was its default priority, to 24576. There is a second method to modify the priority of a switch, which is with the command spanning tree vlan priority. This command allows you to modify the priority with the desired value. Here in this example, we specify the priority 4096. As switches B and C have a default priority of 32769, switch A becomes the root bridge. As the topology of the spanning tree has been changed, the state of port 45 of switch B, which was in a state blocking in the previous example, must certainly have been changed too. This is what we are going to analyze. If we do a show spanning tree on switch A, all of its ports are marked designated because it is the root bridge. The column prio.nbr, right, indicates the value that the switch will have in the BPDU when it sends it through this interface. If we look now on the switch B, the port fast Ethernet 45 leads to the root bridge. It will therefore be marked as root port, and port 44 is seen as not designated and ends up in a blocked state. All we have to do is look at switch C. Port 48 is marked root port, and 43 is a designated port. All the states of this topology, let's play around with the spanning tree. Here, switch B goes through port 45 to join the root bridge, which is switch A. What if we want it to go through switch C to join switch A? It is by playing with the cost of the interfaces that we will be able to change our topology. Here, all of our interfaces have a cost of 19. If we place ourselves on the side of switch B, it can reach the root bridge by its interface 45 for a cost of 19, and its interface 44 for a cost of 38. We will therefore modify the cost and see what happens. The spanning tree cost command is used to modify the cost of an interface. Here we connect to port 45 and specify a cost of 50. If we recall our show spanning tree command, we can see that interface 45 is now blocked, because it has a higher cost than its other interface 44, which is now denoted the root port. With a show spanning tree, without the pipe, we see that the root ID carries the MAC address represented with 2. It is therefore the switch A, and to join it, the cost is 38. Before continuing, we will return to the initial state by deleting our last command. We have just seen that it was possible to modify the original path by playing with the cost of the ports. We will now see that we can also influence the spanning tree by modifying the priority of the port. To see this in detail, we will add an additional link between switch A. And B. If we do a show spanning tree on switch B, we see that on this new link, port 41 has the role of root, and 45 is in a blocked state. So why did the switch decide to block port 45 and not 41, while these two interfaces have the same cost? Well, in this case, the choice is made with the port priority. So be careful. Here, the values that we see on switch B will be used in the BPDU that switch B will send. If switch B prefers to block its port 45 instead of 41, this is because the BPDU received from switch A through port 42 carries a priority lower. The switch will choose the interface through which it receives the lowest port ID. We will now change the priority of the BPDU that switch B receives. It will therefore be necessary to modify switch A. The spanning tree port priority command is used to modify the value of the port priority. Here, instead of 128, which is the default priority, we put it 112. And if now we go back to do a show spanning tree on switch B, this time we see that the blocked port is 41. I hope I haven't lost you. If you are having trouble understanding the spanning tree methodology, I recommend that you build the same topology that I am using and examine your own topology. Play with the priority of the switch, the cost, and the priority of the port to see live the different changes in ports.